Hi there, folks. Sorry I'm not there with you, but here I decided to come up with a little video lesson for you on our calorimetry lab that we worked on from yesterday, where we were burning our flaming hot Cheetos. So what I want to do is I kind of want to walk you through the calculations and what it is that we are supposed to accomplish for this particular lab activity. So first thing first, you need to make sure that you open up your document. So if you need to pause the video, go ahead and pause it and go ahead and open up your document so that you have your calorimetry lab. And what I'm going to be focusing on is analyzing the data that we collected. So that would be, for example, the initial mass of the Cheeto, the mass of the aluminum can, and then the mass of aluminum can with water, the initial temperature of the water, our final temperature of the water after the Cheeto has burned, and our final mass of our Cheeto carcass, as I should say. Okay? So what I want to do is show you how we do the calculation. So I'm starting with question number 1. We're going to ask you to calculate the change in temperature of the water. Anytime you see this delta symbol, all right, delta means change in. Okay, so anytime we see this, we're going to see change in. And so what we're looking at is the change in temperature of the water. So when we do the change in temperature of the water, change in temperature of the water is always going to be the final temperature minus the initial temperature. Okay, meaning what our final reading was compared to what our first reading was. So for my final temperature here, I have it as 36.8 degrees Celsius. So I'm going to show my work as 36.8 degrees Celsius, and I'm going to remove the temperature that I started with, my initial temperature, of 20.1 degrees Celsius. So I ended up with a value of 16.7 degrees Celsius for my change in temperature. Your value will be different than mine, so just double check to make sure that you've done and shown the appropriate work. All of our numbers need to have units, folks, so please make sure that you have your units of degrees Celsius for question number 1. In question number 2, we want to calculate the mass of water in the aluminum can. In order to do that, what we want to do is we want to take the mass of the aluminum can with water, and we are going to remove the mass of the aluminum can. And so what I'm going to do is I'm going to take my mass of the aluminum can with water, which was 88.60 grams, and I'm going to remove the mass of just the aluminum can, which was 12.75 grams. So when I take the difference between these two values, I end up with 75.85 grams of water. Now, I do want to point out your value should be close to 75 grams. And the reason is because the density of water is roughly for every 1 gram of water, it roughly equates to 1 milliliter of water. Okay, just want to make sure that you know that's how I'm going to be checking to make sure that you got the correct volume of water, which we agreed upon is 75 milliliters of water. So this is where it gets fun. This is when we're looking at how to calculate the heat absorbed in calories by the water using the equation given below. So our goal is to figure out how many calories of the energy that the water absorbed. And we're going to use this equation right here, where Q of the water is equal to this value here, which is called the specific heat. And we also have our mass of the water, which we got from our answer. This is question number 2. And our change in temperature of the water, which is their answer to question number 1. So this value here, this specific heat, which I'm going to go into more detail today, you're going to watch another short little video on the idea of how we calculate calories, but specific heat measures the amount of energy it takes for 1 gram of water to raise by 1 degree Celsius. In particular, we measure that either in calories or another unit you're going to be exposed to, which is called joules. Okay, so what we're going to do is we're going to solve for the calories. So we're going to use Q of the water. This is what we're trying to solve. This is basically, if we're looking at it from a mathematical standpoint, this is our X. And we're going to use our constant, which was given as 1.00, and this is calories, which is in the numerator, times grams times degrees Celsius. We're going to multiply that by the mass of the water. So my original mass of the water that I had for question number 2 was 75.85 66.85 grams. Okay, and I'm also going to multiply it by the change in temperature of the water, which was, according to question number 1, 16.7 degrees Celsius. Okay, so when I do this mathematically, what I'm going to do is I'm going to plug into the calculator 1.00 times 75.85 times 16.7. And I get an answer of like 1,266.7. Now, it's fine and dandy I get a number, but numbers mean nothing unless they have units attached to them. So we need to figure out what units we have here. So this is where it's important to recognize what's in the numerator and what is in the denominator. So right here we can see that we've got our line here separating calories and grams degrees Celsius. So calories is in the numerator, while grams and degrees Celsius are in the denominator. Now, in order to show this, I'm going to use a different color here. All right, so what I want us to recognize is that this grams here is actually in the numerator, and this degrees Celsius here is in the numerator. So if we check our units, what we're doing is we're taking calories times grams times degrees Celsius divided by grams times degrees Celsius. And if we check our math, anything divided by itself will equal 1. So gram divided by gram will equal 1. And degrees Celsius divided by degrees Celsius will equal 1. So our units here, we call that canceling out. So the grams cancel out, the degrees Celsius cancel out, and I'll be left in my answer as calories, a unit of energy. So for my final answer here, my 1,266.7 for my answer is going to be in the unit of calories. So this is how much energy was absorbed by the water. Where did this energy come from? That's what I want to know. Where did this energy come from? This energy came from the Cheeto. Well, in particular, the flaming hot Cheeto. Okay? So anytime we have energy, energy is always transferred. We can never destroy energy. Okay? We can never create it. It's just simply transferred. So our last part here, we're working on questions 4, 5, and 6. So in question number 4, this is where we get, we want to know how much of the actual Cheeto burned. And the whole thing did not burn because we actually had remaining Cheeto here. We had leftovers here, folks. Okay, so those leftovers we need to account for because there's only a certain amount that burn. So what we're going to take is the mass of the Cheeto before the burn, all right? And we're then going to take the mass of the Cheeto after the burn. The difference between this is the mass of the Cheeto that actually burned. So my mass of the Cheeto that I started with is 2.20 grams. So 2.20 grams of the Cheeto that I started with. And it ended up that I had a leftover mass of 1.18 grams of the Cheeto. So that means that I actually had 1.02 grams of the Cheeto that burned. Okay, and what we're going to do is we're going to use this for our answer in question number 5. So in this particular one, it's asking us to calculate the amount of energy released by the Cheeto per gram. Okay, the amount of energy, and in particular, we're looking at the amount of energy in the form of calories. Okay, so we're trying to get the answer in calories per gram. Calories per gram. Okay. Now, here's the thing. The amount of energy in the calorie released by the Cheeto will be absorbed by the water. So the Q of the water, which I hope we all recognize that the water absorbed energy, so it's a positive Q, will be equal to that of the Q of the Cheeto because the energy was released by the Cheeto. So literally what we're talking about is this. The Q of the water, which is a positive value, is equal to the negative Q of the Cheeto. So what that means is my answer for question number 3 In question number 3, I had an answer of 1,266.7 calories for the Q of the water. Okay, which would mean that that energy came from the Cheeto, which means that it released 1,266.7 calories. Okay, but the whole Cheeto did not burn, and I want to know the answer in calories per gram. So what I'm going to do is I'm going to divide this by the mass of the Cheeto that burned. Okay, the mass of the Cheeto that burned. Okay, and so that value is my answer from question number 4. Okay, question number 4, which came out to be 1.02 grams. So then what I'm going to do is divide these two values to get my answer in calories per gram. So I end up with a negative value. Everyone should end up with a negative value, and your value will be different than mine, but it should be negative, and I ended up with 1,241.9 calories per gram. That means that the Cheeto released 1,241.9 calories for every 1 gram of Cheeto. Again, the Cheeto released 1,241.9 calories per gram. This is based upon my data. Your data will be different. Okay, everyone got that? Your data will be different than mine. All right, so that gets us to our last question here. Question number 6. I gave you the nutrition label, and I want you to figure out the amount of calories. Calories. Notice it's a lowercase c here per gram of a single Cheeto. Okay, and remember, we're Americans, so we came up with our own system for calories, which we came up with a food calorie, which is 150 food calories. All right, and based upon that, that is in a 28 gram sample. So for food calorie wise, all right, it's 150 food calories per every 28 grams of Cheeto. But I want it in calories, chemistry calories per gram. So one thing we got to recognize, okay, so if I have 1 food calorie, that is equal to 1,000 chemistry calories. Notice uppercase C, lowercase c. Food chemistry. So, using math, I know, this is crazy stuff, along with units, for every 1 food calorie, there are 1,000 chemistry calories. So what I'll do is I'll multiply these together, okay? And so I'm going to give myself a little more space, so get out of here, okay? All right, so 150 food calories multiplied by 1,000 chemistry calories divided by 28 grams and 1 chemistry calorie. Again, my food calories are going to cancel out. So I'll be left with my answer in just chemistry calories per gram, which comes out to be a very large value of 5,357, and that would be chemistry calories per gram for a single gram of Cheeto. So looking at my data, let's see, I was supposed to get 5,357 calories per gram, but I only got 1,241.9 calories per gram. Obviously, something went wrong, and that's where you need to make sure that you try and figure out what went wrong in this experiment, and that is what you're going to be focusing on question number 7. And I'll leave it for you to finish that question on your own.